Welcome to this physics video, which is related with the second PUC physics important 2 and 3 mark questions, which is frequently asked in previous years. We discussed in this particular video. Let us see the first questions, that is basic properties of electric charges. These are the three properties of electric charges. Charges are quantized, charges are conserved, and charges are additive in nature. The three basic properties of electric charges. Next, Coulomb's law of electrostatics. There may ask a statement or state and explain. The statement is like this: the electrostatic force of attraction or repulsion between 2 point charges is directly proportional to the product of magnitude of 2 charges and inversely proportional to square of the distance between them, and acts along the line joining the charges. And expression is F is equal to 1 by 4 pi epsilon naught Q1 into Q2 divided by R square. Next, properties of electric field lines. These are the properties. 1. Electrostatic field lines do not form any closed loop. 2. Two electric field lines never intersect each other. 3. Electric field lines originate from positive charge and terminates on negative charge. These are the properties of electric field lines. Similarly, they are asking properties of magnetic field lines. These are the properties of magnetic field lines. 1. Magnetic field lines forms closed loop. 2. Magnetic field lines do not intersect each other. 3. More field number of magnetic field lines, more stronger the magnetic field. And these are the properties of magnetic field lines. Next, Gauss law in electrostatics. In electrostatics, what is the Gauss law? The statement is like this: the total electric flux through any closed surface is 1 by epsilon times of total charge enclosed by the surface. This is a statement of Gauss law. Similarly, statement of Gauss law in magnetism. In magnetism, Gauss law is stated like this: the net magnetic flux through any closed surface is 0. Net magnetic flux, that is number of magnetic line of force entering to the conductor, is equal to number of field lines leaving the conductor. Like that, net magnetic field is 0. This is a line integral of B vector dot ds vector is 0. This is a Gauss law in magnetic field. Next, capacitors. In capacitor, what is capacitor? A capacitor is a system of two conductors separated by an insulator, in which it is used to store the electric charges or energies. Here is asking what are the factors does capacitance of parallel plate capacitor depends. It depends on 1. Area of the plates, 2. Distance between the plates, 3. Medium used between the plates. Next, they ask to write expression for capacitance of capacitor, that is C is equal to F naught K A divided by D, and they may ask to write expression for energy stored in capacitor. Energy stored in capacitor U is equal to Q square by 2C, or half CV square, or half into Q into V. Next, they ask to derive the relation between electric field and electric potentials, and this is a way we can derive. 1. Consider a two closely spaced equipotential surface A and B with a potential V and V minus delta V respectively. Then work done in unit positive charge is taken along this perpendicular distance from the surface B to A against the electric field. Then work done dW is equal to E into delta L, or minus E into delta L, because the work done is against the direction of electric field. Then work done is equal to potential difference between A and B. Therefore, dW is equal to VA minus VB, or V minus minus delta V. Here V and minus V cancels, and minus of minus delta V become plus delta V. Therefore, we obtain relations electric field E is equal to minus delta V by delta L. Next, state and explain Ohm's law. So, Ohm's law statement is like this: the current through a conductor is directly proportional to potential difference between its ends when its temperature and other physical conditions remain constant. That is, I is directly proportional to V. Then they ask to write limitations of Ohm's law. The limitation of Ohm's law is like this: Ohm's law fails if the relation between V and I is not unique, and Ohm's law is also fails V versus I graph is non-linear, or in case of semiconductors. Kirchhoff laws of electrical network. There will be two laws: Kirchhoff first law or current law or junction rule. The statement is like this: algebraic sum of currents at a node is 0, or sigma I is equal to 0. Second, state Kirchhoff second law or voltage law or loop rules. Statement is like this: in a mesh or loop, algebraic sum of products of current and resistance is equal to algebraic sum of EMFs in that mesh, or sigma IR is equal to sigma E. Next, they are asked to write condition for balanced state of Weiston's network. Balancing condition of Weiston's network is ratio of adjacent resistance of Weiston's bridge must be equal. That is, R1 by R2 is equal to R3 by R4. Next, expression for force acting on a charge moving under a magnetic field. This is expression for magnetic force experienced by a charge Q moving with a velocity V in a magnetic field B, that is given by Fm. Magnetic force Fm is equal to Q into V vector cross B vector, or QVB sin theta. This is expression for magnetic force on a moving charge. Then another law, the Byers and Sever's law. The statement is like this: the magnitude of magnetic field dB at any point P due to this current element is directly proportional to strength of the current I, directly proportional to length of the current element dl, directly proportional to sine of angle between element and line joining the point P to the current element sin theta, and inversely proportional to square of the distance between current element and point P, that is 1 by r square. Totally we can write dB, magnetic field dB is equal to mu naught by 4 pi I dl into r divided by r cube. Next, the Ampere Circuit Law. The statement is like this: the line integral of magnetic field dB vector around a closed loop is equal to mu naught times of total current I passing through this loop. This is a statement of Ampere Circuit Law, mathematical form. The line integral of B vector dot dl vector is equal to mu naught times of I. Then they are asking what is a expression for magnetic field at a center on the axis of solenoid. On a solenoid, magnetic field B is given by mu naught Ni, where mu naught is permeability of a free space, N is number of turns per unit length, and I is a current through the solenoid. Similarly, they may ask what is a magnetic field at a point inside a toroid. There is also same expressions. B is equal to mu naught Ni, that is mu naught is permeability of free space, N is number of turns per unit length, and I is a current to this toroid. Then they are asking how to convert a galometer into ammeter. So ammeter is a device used to measure a current, measurement of current in ampere. This galometer can be converted into ammeter by connecting a low resistance S in parallel with a galometer. Then resistance of ideal galometer is 0. Then how to convert galometer into voltmeter? A voltmeter is a device used for measurement of potential difference in volt. And this galometer can be converted into voltmeter by connecting a high resistance in series with the galometer, and resistance of ideal voltmeter is infinity. Next, the elements of earth magnetic field. What are the elements of earth magnetic field? Magnetic declinations, inclination or dip, and horizontal component of earth magnetic field. And what is magnetic declinations? The angle between geographic meridian and magnetic meridian. Inclination or dip, that is angle between Earth's total magnetic field and its horizontal component. The component of Earth's total magnetic field along the horizontal direction at a place is called horizontal component of Earth magnetic field. The dip is 0 degree and at poles dip is 90 degree. Next, Faraday's law of electromagnetic induction statement. The magnitude of induced EMF in a circuit is equal to time rate of change of magnetic flux through the circuit, or EMF, induced EMF E is equal to minus d phi by dt. And also Lenz's law. The Lenz's law is the polarity of induced EMF is such that it tends to produce a current which opposes the change in magnetic flux that produced it. The statement of Lenz's law. Then asking what is the significance of Lenz's law? It is a law of conservation of energy or polarity of induced EMF. You can get a direction of induced EMF from Lenz's law. Next, eddy current. What is eddy current? The current which are induced when a bulk piece of conductor is subjected to a change in magnetic flux, and these currents are called eddy current. And its uses. It is used in a magnetic braking of trains, speedometers, electric power meters, and induction furnace. They are the uses of eddy current. Next, transformer. A transformer is a device used to change alternating voltage from greater to smaller value or smaller to greater value, and it works on the principle of mutual inductions. And there will be two types of transformer, step up transformer and step down transformer. Then asking what are the source of energy losses in a transformer? The energy loss occurs in a transformer due to one, flux leakage, another is resistance of winding, copper loss, or eddy current loss. They are the energy sources of energy losses in a transformer. Next, types of electron emission. There will be three types of electron emission: thermionic emission, field emission, and photo emissions. They are asking to write equation for Einstein's photoelectric equations. Einstein's photoelectric equation is given: K maximum kinetic energy of a photoelectrons is equal to h mu minus phi naught, where K maxima is maximum kinetic energy of photoelectrons, h is Planck's constant, mu is frequency of incident radiation, and phi naught is a work function of a metal. This is a Einstein's photoelectric equations. Next, experimental observation of photoelectric effect. These are the experimental observations. First, for a given photosensitive material, the frequency of incident radiations, the photoelectric current is directly proportional to intensity of incident radiations. Second, for a given photosensitive material, there exists a certain minimum cutoff frequency of incident radiation called threshold frequency, below which no emission of photoelectron takes place. Third, the photoelectron emission is an instantaneous process. These are the experimental observation of photoelectric effect. Then they are asking to write expression for de Broglie wavelength. The de Broglie wavelength lambda is given by h by square root of 2m q into v, where m is mass of particles, q is charge of particles, and h is Planck's constant and v is charge on the particles. Next, Boost postulates for atom models. So Boost postulate number 1, electrons revolve in a certain stable orbit called stationary orbit. Second, stationary orbit, those angular momentum of electron is nh by 2 pi, where n is an integer 1, 2, 3, etc. When electron make a transition from in a higher orbit of energy hi to lower orbit of energy hf, then photon emission is h mu is equal to ei minus ef. Next, limitation of Bose theory. The limitations: number 1, Bose theory is applicable only hydrogen-like atoms. Second, the origin of fine structure of the spectral lines of hydrogen could not be explained by Bose theory. This is a limitation of Bose theory. Of nuclear force. Nuclear force is the strongest force in nature. Nuclear force is a charge independent force. Nuclear force have a property of saturations, and nuclear force is attractive force, and nuclear forces are short range force. These are the properties of nuclear force. Next, nuclear fission. The splitting up of a heavy nucleus into two lighter nuclei of comparable masses with the liberation of energy is called nuclear fissions. Equation is given: 1 neutron plus uranium is reacted with produce barium and krypton plus 3 neutrons. Similarly, nuclear fusions. It is a process in which two lighter nuclei fuse to form a heavier nucleus with the release of energy. Example, two hydrogen atom combine to form deuterium with them positive positrons with a neutrino Abdel 0.42 MeV of energy. Next, distinguish between eccentric and intrinsic semiconductor. There are differences. In intrinsic semiconductors are pure semiconductor crystals. Eccentric semiconductors are semiconductors doped with them impurities. And intrinsic semiconductor contains same number of electrons and holes. Eccentric semiconductor, number of electrons and holes are not same. Then intrinsic semiconductor conductivity is because of both electrons as well as holes. In eccentric semiconductor, conductivity is mainly due to majority charge carriers. Next, distinguish between p-type and n-type of semiconductor. The p-type of semiconductor is formed by when a trivalent impurity is doped with an intrinsic semiconductor. N-type of semiconductor is formed when a pentavalent impurity atom is doped with an intrinsic semiconductor. And p-type holes are majority charge carriers. Positive charge carriers are more. In n-type, electrons are majority charge carrier. The negative type of charge carriers are more. And in p-type of semiconductor, impurity atom is called acceptor impurities. In n-type of semiconductor, impurity atom is called donor impurity atoms. Next, they are asking some diagrams like this. Sketch the electric field lines of forces due to a point charge. Point charges may be a positive unit charge or negative charge, or to unlike charges or to like charges. Also sketch the magnetic field lines due to a bar magnet, is shown in figure. Same way, they are asked to draw a graph represent variation of resistivity with the absolute temperature for a copper, for a nichrome, for a semiconductors. Also, the classification or distinguish is solid into insulator, metals and conductor based on energy band diagrams. This is an energy band diagram for an insulator, semiconductors and conductor. There will be large energy gap is more than 3 electron volt. In case of insulator is a moderate energy gap. This energy gap is less than 3 electron volt. In case of semiconductor there will be no energy gap. Bands are overlaps in case of metals or conductors. Next, they are asking to draw a circuit symbol and truth table for a NOT gate, for a NOR gate, for an AND gate. That's the logic gates, basic or fundamental gates. And logic gates for a NAND gates, NOR gate. They are called universal gates. Is a circuit symbol and truth table for NAND gate and NOR gate. And also they are asking to write uses or applications. For a gamma rays, it is used for cancer treatment and sterilizations. X-rays are used to detect fractures in bones or treatment of some cancers. UV rays are used in a LASIK or eye surgery in detection of fingerprints. IR or infrared rays are used to remote controls, or IR rays are used in micro ovens